Welcome to Spring LIB.
Okay, we need to draw an MO diagram for any 2 plus, or the doubly positively charged ion of diatomic neon. Okay. Well, recall that, in terms of the periodic table, we're saying carbon, nitrogen, oxygen, fluorine, neon, right? Meaning that this is a row 2 compound, right? So it's going to be just like, C2, N2, O2, F2, Ne2, really, right? That is, we should expect to have, one s orbitals that overlap, 2 s orbitals that overlap, and 2 p orbitals that overlap. And that's going to be the foundation of our molecular orbital diagram. So I've got a template here of exactly that, right? But this is blank, right? So theoretically, you could take something like this and fill it up for any diatomic from row 1. And here we're going to do Ne2, right? So what that means is that we're going to have Ne plus over here and Ne plus over here. And the question is, how many electrons should Ne plus have? Well, neon itself, we know it's a noble gas. It should have 8 electrons in its valence shell, right? So not counting the 1s orbital, which is not in its valence shell, which we should expect to be full, we should expect that Ne plus has 7 electrons, right? And that's going to be true for either side. And we should know that its inner shells should also be full, right? Because how would we get to the outer shells, right? So 2 electrons in each of the 1s orbitals, meaning a total of 4 electrons in the sigma 1s and sigma star 1s. Okay, but that's sort of besides the point. They're there, but they don't do anything. They don't increase the bond order, right? Okay. So now we move on to the important ones. 7 electrons that I should fill into Ne plus. Well, I know I'm going to fill the s orbitals first, one up, one down. I know I'm going to fill the p orbitals one at a time until I have to start doubling up. And, oh, there we go, 7 electrons. Okay, same thing over here, 2 into the 2s, 5 into the 2p, one at a time until I have to start doubling up. And, oh, then I've hit 7. Okay, so these are the electrons that we have to work with, and we are simply going to fill them in from the bottom up, right? We can see rather simply here, we've got 2 electrons on either side of these sigma 2s molecular orbitals, so I can just do 1, 2 in the bottom, 2 in the top, no problem. Now I've got 5 electrons to fill into these p orbitals, right? So sigma 2p, I'm going to do 1 and 2. Pi 2p is going to be 1, 2, 3, 4. Okay, so now I've used a total of 6 electrons, right? I've got 4 left, so I'm going to get 1, 2, 3, 4 into the pi star 2p's, and that's it. That's all 10 of my electrons, okay? That's really it. I mean, what it tells us is that the bond order would be 1, right? But this is the diagram that you would need to arrive at.